Hey guys, welcome back to another set of notes. We're on lesson 2-5, comparing and ordering rational numbers. Today's date is 12/10/19. So we've got a couple sets of notes, probably at least a total of 3, maybe 4 this week. And then we'll be reviewing and wrapping up and hopefully taking the chapter 2 test before we go on break. And so what I wanted to do is start with the word rational number, the words rational number. We've talked about this. Gosh, I can't remember what set of notes it was. Maybe it was in the beginning even. But this is a really important term, and you're going to be using it for years. So rational starts with that word ratio. Okay, that's how I kind of think of rational number, is it has a ratio. And remember that ratio is a fancy way of saying fraction. Okay, so that's just a little reminder. But here's the definition of a rational number. It's any number that can be written as a ratio. So, I always do that, don't I? As a ratio, that's a comparison of two numbers. So this includes fractions, decimals, and percents. So all the things we've been studying in this chapter are all considered rational numbers. Now there's other things that can go in rational numbers, integers, and you'll learn more about those. We might even touch on that in this class in a little bit. Okay, so to compare and order rational numbers, there's some things that we need to review what we're going to end up doing. Okay, so I'm going to give you some suggestions and whatnot. So first thing I want to do is talk about this idea of least common denominator. Now, we've been talking about least common multiple at the beginning of chapter 1, I think it was. And so a least common denominator now is specifically looking at the denominators of some fractions. So it is the, least common multiple of the denominators of two or more fractions. Okay, now why that becomes important in this lesson is because we may have to compare and order. So compare, how does this one, is it larger, is it smaller, is it equal to, and then we may have a whole slew of fractions and we have to put them in order from least to greatest or greatest to least. So we're going to talk about this in terms of comparing and ordering fractions. So sometimes in this lesson, you're going to compare just fraction to fraction, mixed number to mixed number. Sometimes you're going to compare a decimal to a fraction or a mixed number. Sometimes percents could get involved. So all sorts of different ways of comparing these guys. But we're going to look at these. So sometimes you may want to change your decimals to fractions, or your fractions to decimals, just depends. Just order. Compare and order fractions. So here's some suggestions of what you would do to compare and order fractions. First, I should go back here. We usually refer to least common denominator as LCD. Okay, so we're going to find the LCD of the fractions. Okay, And once we figure out what is a common denominator, then we're going to create equivalent fractions. Remember, we talked about those as well earlier. Write an equivalent fraction for each original fraction using the LCD as the denominator. And remember, what that means is whatever I had to multiply the denominator by to become the LCD, I have to multiply the numerator by the same thing. Once we get the denominators to be the same, then the problem becomes really simple, because at this point we're just going to then compare the numerators. So you cannot compare two fractions until the denominators match. Once the denominators match, then you just look at the numerators, okay? So this brings up another thing called comparison symbols. Oops, having trouble spelling tonight. There we go, comparison symbols. So when I'm comparing, the first number could be greater than the second number. Another way could be the first number is less than the second number, or the two numbers are equal to each other. Now, remember how inequalities work. That's what greater than and less than are called, are inequalities. I think your teachers used to say something about the hungry alligator. He always likes to eat the bigger number. So his big mouth is always open towards the bigger number. So if his mouth is the first thing you see, that means greater than. The first number is greater than the second number. If his mouth is turned away from you, that means the second number is greater, and we say the first number is less than the second number. Okay? And if you haven't heard that, now you have. All right, let's talk about comparing fractions. Decimals. And percents. So we can have any combination of these. So here's some suggestions. And these you kind of have to figure out for you which works best. But the order that I'm listing them is going to be what I would do. I think it's the fastest way to solve these problems when they aren't all fractions or all decimals or all percents. I would rewrite each value as a fraction. It is the fastest way to change all our different guys, all our different types of rational numbers, is to, oh, sorry, not fractions. Where's my brain tonight? As a decimal. That's the fastest thing to do. Okay, so we're going to rewrite each value as a decimal. Excuse me. Then compare the first place value column can't spell value very well. Let's try that again. That has different values. So you're going to start with the largest place value column, and then you're going to go, if they're the same, go to the next one to the right, so it's one smaller. If they're the same, you keep going until you finally see a difference, and then that's how you're going to compare the two. So that's what I would recommend when you have a mixture. The other thing is that you can graph things on number lines. So number lines are useful to compare values. Okay, so I'm going to go ahead and flip over to our little glue in examples, and let's get started on them. So for first two, say fill in each circle with less than, greater than, or equal to make a true statement. Now in both cases we have matching fractions, or we have two fractions, not matching, but two fractions. So what I want to look for is the LCD. So I'm looking for the LCD of 3 and 9. And what I'm going to do is test. Can the smaller denominator go evenly into the larger denominator? Can 3 go evenly into 9? And the answer is yes. So that means the LCD is 9. So we're going to create two new fractions with 9 as the denominator. So going back to our problem, 3 times 3 equals 9, so 2 times 3 gives me 6. Now in the second one, the denominator didn't change, so the numerator doesn't change. So notice what I'm doing. I am taking and I'm writing an equivalent fraction for each of the original ones below them. I don't switch the order, that would be disastrous. Okay? Now, all I'm going to do at this point is look at the numerators, because that's the only thing where something's different is in the numerator. And I notice that 6 is greater than 4. It's bigger. So that allows me to take that relationship and put it in the circle. 2/3 is greater than 4/9. And that's the solution to this problem. All right, let's try the next one. We have 5/12, and we want to compare it to 7/8. And some of you might say, I can do that without having to show work. Yeah, you still have to show work for me, my friends. You still have to show work. So I need to find the LCD of 12 and 8. So if you can't remember or you can't figure it out, remember, let's use our factor ladder. So we'll take our two numbers and we'll look for factors they have in common. So you might say, well, they're both even, so let's factor out a 2. 2 goes into 12 6 times and into 8 4 times. Oh, look at that, they're still both even. So we'll add another ladder rung and pull out another 2, and 2 goes into 6 3 times and into 4 twice. I don't have any other numbers that they have in common other than 1. So then I circle up all the outside numbers, and I'm going to multiply all of those outside numbers together. So 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. So I've just come up with the common denominator. Now some of you may argue and say, well, I could have done that in my head. I didn't need to do that. Fine, that's great. That's awesome. Do it. Okay? So what did I do to 12 to make it 24? Oh, I doubled it. So I'm going to double the 5, and that gives me 10 24ths. The other one, I had to multiply 8 by 3, so I'm going to multiply 7 by 3, and I get 21. So remember, the equivalent fraction for each of them is directly below the originals. All I do is compare my numerators, and I notice that 10 is smaller than 21, or less than. So then I take that answer, and I can put it back in with the original problems. So 5/12 is less than 7/8. Okay, next problem. They want me to take 1/2, 5/6, 2/3, and 3/5, and they want me to figure out what order they would be from least to greatest. So let me just talk about that. Least comes first, greatest is at the very end. Okay? All right. So off to the side, let's go ahead and do LCD. We have 2, 6, 3, 5. So when I have 3 or more numbers, all I look is something that at least 2 of them have in common. Well, 2 and 6 are even, so I'm going to divide out of 2. So 2 divided by 2 is 1, 6 divided by 2 is 3. I can't divide 2 into 3, and I can't divide 2 into 5, so they just come down. Do you see anything that at least 2 of them have in common? Yep, I see a 3 myself. Let's see. Can't go into 1, 3 goes into itself once, and 3 goes into itself once, and it can't go into 5. So again, we're going to grab all those outside numbers, those outside factors, and we're going to multiply them together. So 2 times 3 is 6, times 1 is 6, times 1 is 6, times 1 is 6. 6 times 5 is 30. So that's going to be my common denominator. So I'm going to create new fractions with 30 as the denominator. Okay. So 2 times 15 is 30, and 1 times 15 is 15. 6 times 5 is 30, and 5 times 5 is 25. 3 times 10 is 30, and 2 times 10 is 20. 3 times 6 is 30, or 5 times 6 is 30, and 3 times 6 is 18. So now what I'm going to do is look at these numerators only. And I'm going to write underneath which fraction is the smallest to which one is the largest. Well, 15 is the smallest of the numerator numbers, so that's the first fraction. That corresponds to 1/2. That's your least fraction. Next smallest would be the 18 30ths, and that pairs up with 3/5. So that's your next. And then 20 comes in third place, and that corresponds to 2/3. And the last one is 25 30ths, which actually corresponds to 5/6. So this would be your correct answer. And the big message I need you to hear from this is you must put original values in order. Okay, not the ones that we gussied up to get all the common denominators, just the ones that we had originally. All right, so let's do a couple where it's mixed values. Okay, so here's where you're going to see me use that strategy of changing anything that's not a decimal into a decimal. So first problem, I've got 0.7 or 7/10, and I want to compare it to 8/11. So off to the side, I shall do it over here. I'm going to take 8, I'm going to divide it by 11. Now, if you're getting a whole number and then leftover answer, you know you've done it wrong, because 8/11 is less than 1. So keep that in mind. 11 goes into 87 times, which is 77. When you subtract, we get a difference of 3. Annex another 0. 11 goes into 30 twice, which is 22. With 8 left over. And what you notice here, we're going to have repeating. And what's going to happen is we're just going to keep getting 72, where 80 and 7 will go in 77. We'll have a difference of 3, and we'll just get 72, 72, 72, and so on. Okay? So we really don't need to go that far, because what we're going to compare is our original 0.7, but because my other number also starts with 0.7, we are going to have to extend it to its second digit. So that means with my first number, I'm going to put a 0 there. So remember how I said, excuse me, that we're going to compare the first place value, we get to where there's not the same number. So if I looked at the ones column, they both are a 0. That doesn't help. I go to the tenths column, they're both a 7. That doesn't help. And then I go to the hundredths column, and finally I see a difference, and I'm actually comparing 0 to 2. I know that 0 is less than 2, which means 0.70 is less than 72 hundredths, which allows me to conclude that 7/10 is less than 8/11. Okay? All right, let's do the next one. I'm going to do it off to the right here. We have 1 divided by 5. Put in a decimal point, bring it up. 5 goes into 10 twice. So this is called a terminating decimal because I have no remainder, whereas the one before was a repeating decimal. If I were to write the answer before, just to let you know, I would have written it as 0.72 with a repeating bar over the 7 and the 2. Careful to not make it go over the decimal point because that would be weird. All right, so getting back to the matter at hand, this gives me 0.2, and we're comparing it to 0.2. Well, I don't know about you, but that looks pretty much the same thing. Since those two are equal, that means 1/5 is equal to 2/10. All right, next one, we have 42%, and we want to compare that to 0.44, or 44 hundredths. So we're going to change the percent to a decimal by dropping off the percent symbol and then dividing by 100. So that gives me 0.42, and we're going to compare it to the well, actually, let me do that one in black. 0.44. And then we're going to go ahead and compare place value columns. So we start with the largest one. The ones, nothing. They're the same. 4 and 4, they're the same. But again, when we get to that hundredths, I have a 2 versus a 4. So this is what I'm actually comparing. 2 is less than 4, which means 42 hundredths is less than 44 hundredths, which means 42% is less than 44 hundredths. All right, last one. Hiroshi found that 3/5 of his classmates prefer vanilla ice cream, 26 prefer chocolate, and 14 hundredths prefer strawberry. What kind of ice cream do the students prefer the least? So I'm going to do this one off to the side. So basically what we're trying to compare is 3/5, 26%, and 14 hundredths. So I'm going to start with that 3/5, and I'm going to write it as a division problem. So put in a decimal point and annex a 0, and 5 goes into 36 times evenly. So we have a terminating decimal. So this guy is 0.6. The next one, we're going to go ahead and cross off the decimal point because or the percent symbol, we're going to divide by 100, and that gives us 0.26. And then the last one's already a decimal, so we're just going to bring him down so we can compare. So what I notice is that all of my numbers, except for the first one, have a 0, or have 2 digits after the decimal point. So we're going to annex a 0 there. So what I'm looking for, okay, I'm sorry, my kitty cat is like rubbing all against my iPad right now. So silly. Oh my gosh. So we're going to look at the ones. We have a 0, we have a 0, we have a 0. That doesn't help. We look at our tenths. We have a 6, we have a 2, we have a 1. So we're comparing those 3 numbers. And the one we're interested in is the one that is the least, which is 1, which goes with this guy. Okay? So we look for what 14 hundredths goes with, and that's strawberry. So we would draw a conclusion, and we would say students prefer strawberry ice cream the least. Poor strawberry ice cream. Or it looks like the winner is going to be vanilla, followed by chocolate. I'm not sure if I agree with that. Anyway, that's up to you to decide. So that's what we're going to be working on, guys. Good luck with it. We'll see you later. Bye.